I'm Greg Johnson. What I'm showing today is high-performance photorealistic rendering. The idea is that if you are an architect, for example, and you're designing a building for a client, you'd like to be able to show the client what the building is going to look like, down to the individual surfaces in the building, how they're going to look under various lighting and so forth. So the software that we have here is designed to do exactly that type of calculation. Car companies, aircraft manufacturers, movie studios all use this type of rendering software to generate images of geometric models that are indistinguishable from photographs. Because this software is simulating the physical propagation of light, so photons coming out of a light source, bouncing off of a surface and hitting the camera, it's very expensive. Traditionally, this type of calculation takes minutes, hours, or even days. What we're showing here is a highly optimized renderer for Intel CPUs that generates the same images in several seconds. And it's progressive, so as I move the crown around, it looks sort of fuzzy, and then if we give it several seconds, it will refine it more and more. And you can start to see individual details, like in the gold here, you can see the reflection of the jewels in front of it. On the satin, you can see subtle reflections in it. The gemstones, you can see the internal reflections. We get nice shadows. The crown is casting a little bit of shadow onto the velvet. And we're also modeling a physical camera lens. So, like your DSLR, it has a limited focal depth, and you can see that in the image, where we're getting fuzziness out towards away from the lens. And then when we're in the focal range, of course, we get nice sharp images. So here you can see now some reflections from the windows that are in the room above the object. And in fact, I'll move it again, and we'll see if we can get some interesting reflections in the gemstone here. This is actually the hardest part of the model to render, because the photons bounce around inside the gemstone, and it takes several seconds to get it completely filled in. But already you can start to see that there's a light source that we're reflecting. There's clearly some windows back here. You can see it's getting sharper and sharper.
That's really amazing.
There's lots of subtle details here, like you'll notice that the satin is a little bit red along this edge. This is because the satin is actually reflecting light from the velvet beneath it. Similarly, you can see the gold underneath here is reflecting the red of the velvet that's inside. And so all of these nice little details we can get using this technique. In computer games today, if you play computer games, you don't get this quality of graphics.
Well, I can't wait to see it roll out on computers. Thank you.
You're welcome.